Hi guys. Okay, so today we're going to look at the natural log function a little bit. So the first thing I want you to remember is that a log is an exponent. So that if y equals log base b of x, that means that b to the y equals x. That this y is the exponent. The log is equal to the exponent. All right, now remember the natural logarithm, that's when the base is e. So y equals log base e of x means that x equals e to the y. However, we don't write y equals log base e of x. We write y equals ln of x, but we never read it y equals ln of x. We read it y equals the natural log of x. And you had some properties last year and in Algebra 2 for both logs and natural logs. Remember, when you're taking the log of a product, because logs are exponents, when you multiply, it becomes addition. You add those exponents. Just like with the laws of exponents, when you divide, you actually subtract the exponents. The natural log of 1 equals 0 because that's asking you e to what exponent gives you 1. Well, that would be e to the 0. And that's why the natural log of 1 is 0. And this is one that you need to know because you're never going to leave natural log of 1 in your answer. Because the natural log of 1 is 0, we know that this natural log of 1 over x, because of the division, is the natural log of 1 minus the natural log of x. That becomes negative natural log of x. We also know that when we raise an exponent to another exponent, we multiply those exponents. So when we have the natural log of x to the n, that n comes down front and we multiply the exponents. N times the natural log of x. Two other properties of logs that you need to know, that a to the log base a of x is x. This is one that you guys didn't like so much last year. Remember, if 2 raised to the log base 2 of 8, what is that? That's 8. Because 2 to the third is 8, then you're going to raise 2 to that 3, you're going to get 8. That's what that first one says. Now the second one is the change of base rule. And this one's going to be important for us. And it doesn't matter what base you use. If you have the log base a of x, you can change that to the log of any base of x over the log of the same new base of a. Now the reason I wrote it this way is because this is the one we're going to use a lot this year, because you're going to find it's easier to take the derivative of natural logs than it is to take the derivative of logs of other bases. Most of you anyway. Do you remember how exponentials and logs are related? All right, let's see if we can remember here. If we let y equals e to the x, and we want to graph it in parametric mode, we're going to let x be t, and in y we're going to put e to the t. That'll graph for us e to the x. Then we want to graph the inverse, so all we're going to do is we're going to switch the x and the y's. Okay, so now I'm going to come here. Now I'm on my iPad, so it looks a little different than you're used to. In here, I'm going to go to my tools. Instead of function, I want to use parametric. And we said we're going to use t. And then underneath that, in the y's, we said we're going to use e raised to the t. Okay, I'm going to hit enter. There's our graph because we only started at 0, so we're seeing it from there. Then I want to go back up. Okay, now I want to go back up and we're going to graph the inverse. So now we're going to graph e to the t. And then we're going to graph the t, and we press enter, and you can see that these are inverses. They're reflections over the line y equals x. So it turns out that our logs and our exponentials are inverses. So let's write that down there. How are they related? They are inverses. That means that if x equals e to the y, that only happens if y equals log base e of x. And we write the log base e of x, remember, as the natural log of x. That also means that y equals 2 to the x is the inverse of y equals log base 2 of x. There's also something called the common logarithm. Do you remember what that is? That's where the base is 10. So something like y equals log base 10 of x is only true if x equals 10 to the y. But again, we don't write y equals log base 10. We just write, it's so common we don't even write it. We just write y equals log x. Okay? Now, some things about log functions and their graphs, if you think about them, I'm going to go back for a minute. Let's go back to my TI calculator and let's just do, okay. Let's just graph, say, the natural log of x in function mode. There it is, okay? Notice what the domain is. All the x's to the right of the y-axis, so the x is greater than 0. The range, it goes forever low to forever high. It passes through that point 1, 0. Remember the rules we had for the exponentials? Anything that was related to x is now related to the y's. Anything that was related to the y's is now related to the x's. So the domain is x is greater than 0. The range is all the reals. All the exponential graphs pass through the point 0, 1. All the log graphs pass through the point 1, 0. The exponentials had a horizontal asymptote at y equals 0. The logs have a vertical asymptote at x equals 0. Now, do you remember when we looked at y equals e to the x and then we looked at its derivative? Let's see if we can see the same thing for the natural log. So let's go back. We already graphed the natural log of x. Okay, so let's go back up and we're going to use our derivative tool now, the derivative with respect to x of, and we can either type in f1 of x, but this time on this particular keyboard, I think it's going to be easier for me to type in the natural log of x. Oh no, that is definitely not the same, is it? Definitely not the same thing. Wow, what are we going to do? Okay, so instead, let's go up here to the tools and let's look at a table. Let's look at a split screen table. Here are my x values and my derivative values. When x is 1, the derivative is 1. When x is 2, the derivative is 0.5 or 1/2. When x is 3, the derivative is 0.333, which is 1/3. When x is 4, the derivative is 0.25, which is 1/4. When x is 5, the derivative is 0.2, that's 2/10 or 1/5. Do you guys see what the derivative is? The derivative with respect to x of the natural log of x is 1 over x. And remember, that also means that the derivative with respect to x of the natural log of u is 1 over u times du dx. And this is just your reminder to use the chain rule. Okay, so let's try some. Let's find dy dx. So the first one here, y equals the natural log of x cubed plus 2x. So dy dx, when we take the derivative of the natural log, it's 1 over whatever we were taking the natural log of, times the derivative of this inside. So the derivative of x cubed is 3x squared, plus the derivative of 2x is x. That means that our derivative of y with respect to x is 3x squared plus 2 all over x cubed plus 2x. And we have our first derivative of a log. Now let's look at y equals the natural log of x cubed. And there's at least 2 ways to do this problem. If we follow the rule says the derivative of y is dy dx. Derivative of natural log, it's 1 over, we're taking the natural log of x cubed, times, now we take the derivative of the x cubed, that's 3x squared. So when we multiply that, 1 over x cubed times 3x squared is going to give us 3 over x. And there's our derivative. Perfect, marvelous. Now some people might look at this same problem, y equals the natural log of x cubed, and say, wait a minute, isn't that the same as y equals 3 times the natural log of x? And then my derivative is just 3 times the derivative of the natural log of x is 1 over x. So that's just 3 over x, and they get the same answer. Do I care which way you use? Nope, not at all. Your call, guys, okay? Now let's do y equals the natural log of the sine of x. So if we take the derivative of y, it's dy dx. which becomes, now the derivative of natural log is 1 over whatever we're taking the natural log of, which in this case is sine x, times the derivative of sine x is cosine x. So that's cosine x over sine x. But don't we have a better name for that? That's just cotan x. See, this isn't so bad, right? What happens if we switch it around? What if we do y equals the sine of the natural log of x? So the derivative of y with respect to x, we take the derivative of sine, which is cosine, keep the inside angle, times the derivative of the angle is 1 over x. So couldn't I just put it over x? These are your favorite down here. If f of x is the natural log of x, what is this? Now this should be ringing alarm bells, but Chris is saying, wait, I see it. Look, there's a 2 first, but then the 2 is last. The x is last and then the x is first. You're right, Chris. We need to switch that around and take out the negative. Negative limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Now, that's really the negation of the derivative of f at this x value 2. Well, guys, don't we know the derivative of f of x? The derivative of the natural log is 1 over x. So what's the derivative at 2? It's 1/2, which means that the negation of the derivative at 2 is negative 1/2. Be careful you get that negative, okay? Okay, so this is where we're going to stop for today. So make sure you know your rules for how to find the derivative of the natural log. See you soon, guys. Bye.